This is A2Pure Maths. We're on chapter 5 and we're looking at transformations. The previous video just revised this stuff from AS transformations. So here we're looking at combined transformations. So for A2 we need to be able to maybe move it to the right and then stretch it up and down and things like that. So that's what it means by combined transformations. Often asked to transform a graph using a combination of the types 1 to 4 that you've met in the previous one. In most cases the order in which we carried the transformation over does not matter. However, there are two cases where the order does matter, and it's in these two here. So the AX, what does that do? If you remember, that squeezes it in, and then this B, that would move it kind of left or right. So but it's because it's the X coordinate that's affected both times here. You need to be careful with the order you do it. We'll look a bit down here. The other one here, so A, f of X, what does that A do? It stretches the graph vertically this way, and the B moves it up and down, and again that bit's important. So the other ones don't matter. You can just do this bit and this bit, or you can do this bit first and this bit, and it won't actually affect it for any of the other ones. The two that do matter are these two here. So let's take a wee look why. I'll run over very quickly. The combinations affect the same part of the coordinate, or the combinations of the order that matters. So as I said here, this one stretches in, the squeeze in, the X coordinate changes here, the X coordinate changes here. So it's the same part of the coordinate. Consider f of X plus B. Y coordinate will not change under either transformation. So the Y is the same as in f of X, and the Y coordinate is the same for f of X plus B. So if we set those equal to each other and then rearrange, we're trying to work out what the new X coordinate is. So the new X coordinate is X, the old X coordinate, take away B divided by A. So how would you do that algebraically? You do the B bit first and then you divide by A. So in this case here, we need to remember you do the B bit first and then divide by A. So B part of it first, then A, horizontal, and then compression. For this one here, Y is f of X and Y is A f of X. So if we can put these equal to each other, or substitute it in, sorry, we get Y minus B equals A f of X, rearranging this. Then Y minus B over A is f of X. Therefore our Y is equal to Y minus B. So move this around so we can see it. And then effectively when you get down here, it's Y equals AY plus B. So how do you do this algebraically? You'd multiply by A and then you would add B. So in this case you do the A part of the combination first and then the B. So we're going to take a wee look at one example of that, and I'm going to flick back and forward so we'll hopefully understand then what's going on. So below is a graph of Y equals f of X. This is it down here. On separate diagrams, sketch the graphs of Y equals minus f of X plus 3. So the minus out the front here flips this, because the minus involves this stretch here. So it flips this in the x-axis, and this 3 then is going to move it up. So which form is this one? That's this one here. So what do we have to do first? We have to do the A part first, and then we got to do the B. So what's this going to do? This here is going to flip it in this axis here. If we wanted a very little diagram about what's happening here, let's see if we can get it, if I can work out what was, it's going to end up going like that, if that makes sense. And then the plus 3 is going to move everything up, then 3 coordinates. So that was currently then at minus 3. So that's going to go up then to 0. Let's actually draw this on here, hopefully you'll be able to see. Like that. And then a line going down like that. Here's my new point A, which is what they want us to put on. Hasn't moved left or right or anything, that's just the same. So that's the point 2. And then that was at 0 in that previous one. So it's going to be moved up then to 3. Okay. This next one, Y equals 2x minus 1. So the 2 squeezes it in quite as close. The minus 1 is going to move it then to the right 1. Let's see which of the two that is. So it's this form here. So we actually have to do the B part first and then the A for these reasons here. So the B part first is we want to move everything to the right 1. Again, I'll do a wee mini diagram in between. That's not going to be quite crossing at 3 this time, that's okay, but the important bit here is that this is now a 3, it's moved to the right 1, and then the 2 is going to squeeze it in twice as close. So this is going to move from 3 to 1.5 and be like kind of a squeezed in version of that. So hopefully that makes sense. Sorry, you can't even see that. and that then is the point 1.5, which is your point A, and it's obviously on the axis. The other ones make no difference. These are the kind of two important ones, where the order in which you do it does matter. Here's what I mean by that. Say for example you were to move this one up 3 first and then flip it around, you're not going to get the same answer as this. So with the theory behind it is these wee bits here, which has just been 3, and so that's the way we transform combinations of graphs.